Hello, make yourself comfortable. In this video we're going to discuss piecewise functions. Piecewise functions. So you're probably familiar with the function like this one, the quadratic function, or the linear function, or even functions of the form y is equal to a to the power of x, the exponential function. But in this lesson we're going to discuss, again, piecewise functions. And from the name, piecewise functions are functions that are made up of pieces of functions that make up a piecewise function. And those pieces are defined on an interval. A function made up of pieces of other functions. Other functions that could be quadratics, lines, and defined on intervals. Just like how a function is defined on an interval, which is its domain, could be the real numbers. Piecewise functions are defined on intervals. Piecewise functions have intervals that define those pieces, those functions that make up the whole piecewise function. This was just a rough explanation. Let's head into an example and we'll understand more there. Okay, here we have a piecewise function, a simple example. Now what's the first thing we notice? There are pieces, different bits and parts that make up this piecewise function. That's why it's called a piecewise function. And what else do we see? Each of these pieces are defined on intervals. Sorry, here. Great. Now how would we represent this function? Well, we would write any function, f, g, h. Let's go with f. Standard way. F of x, the piecewise function, is equal to, well, we have three parts. So we're going to leave three spots for us to write these three pieces that make up this piecewise function. That's a good way of thinking of it. And each of them defined on some interval. The domain of each of these pieces. Okay, so let's start on the left side. So down here you see we have this piece. Well, we notice it's a constant function. It's the constant function. Y is equal to -9. Because here the value is -9. So it's a constant function. So we would write -9. What's the corresponding interval this function is defined in? Well, we see from -9 to -3, not including -9. So for all the values greater than -9 and less than or equal to -3. Greater than -9, less than or equal to -3. Because -3 is included, filled in. -9, excluded, not filled in. What do we have next? Well, we have up here, next we have another constant function. See? Constant functions make up this piecewise function. This one is 6. It's equal to 6. That's the piecewise function. And the interval from -3 to -1. -3 is not included. So we would write -3 greater than -3 for all x greater than -3, less than or equal to -1. -1 is included. Notice here -3 was included, but now here -3 is excluded. Because if this -3 here was included, then we would have a filled in hole here, and the function would be defined all over here. And so we would have this defined point here, and by the vertical line test, 2 intersection points in the function, so it's not a function anymore. That's why this is an unfilled point, and we write greater than -3. For 6, it's greater than -3. We're not including 3. And then we head over down here, and we see we have another constant function. We have another constant function, -7, that makes up this piecewise function. And we are excluding -1. See, it's unfilled here. So for all x greater than -1, not including -1, all the way up to 9, including 9. So we would write, and it's defined on this interval from -1, so for all x greater than -1, not including -1, and less than or equal to 9. So here again not including -1, less than or equal to 9. And that's how we define our piecewise function. More examples in the examples playlist. This was a basic example. Thanks for watching. Find my blog below. Send me an email with anything related to math. Thank you.